The write operation performed by type 1 and type 2 packets have the purpose of writing to specific configuration registers. The registers of Xilinx FPGA can be found in the corresponding configuration user guide, which is part of the public available documentation provided by Xilinx. Each of these registers controls a particular feature of the device. For the purpose of understanding the configuration process, some of the relevant registers are the CRC, ID code, FAR, and FDRI registers, just to name a few. All the other registers are used for controlling aspects other than the configuration. Again, for more detail, I love to invite you to consult the documentation of the FPGA family of your interest. The Cyclic Redundancy Check register, or CRC, for simplicity, is used to check the correct transferring of the configuration data by storing the results of a standard 16-bit checksum algorithm. The bitstream has a pre-calculated checksum value at the end of the configuration words, that is checked against the value calculated by the configuration logic. If the two values don't match, an error situation is created, and the configuration process must be repeated. The CRC verification can be disabled for each family by setting the appropriate bit of the configuration optore register, or COR. Not really sure I'm going to suggest you of doing it, but it's good to know that you may have this option. To avoid the downloading of a bitstream created for the wrong device, the ID code register must be written with a 32-bit word that is unique for every device. This word is also hardwired into the configuration logic, and the comparison of the contents of the register with the hardwired value can determine the correctness of the bitstream. The frame address register, or FAR, from now on, is where the position of the first configuration frame is written, and it is thus important for knowing the physical location in partial bitstreams. This register is automatically incremented by the FPGA's configuration logic when the words that make up a configuration frame have been received, in such a way that only the first FAR value must be present in the bitstream file. The frame address register is broken up into different fields, depending on the specific FPGA family taken into consideration. The frame address register formats are defined again, guess where? In the configuration user guide. It seems we do definitely have to get familiar with these documents if we want to properly understand how our FPGAs are configured. The terminology used in the manufacturer's user guide has been updated to be uniform across every family. The block type field of the frame address register indicates broadly what kind of resources the frame with that value will configure. Different types are allowed: configuration of CLBs, IOBs, interconnect and block special frames, block RAM content, and so on. The column address field indicates what column of resources in the frame is currently configuring. Note, as you can also see from the figure, the column is made of different frames. Therefore, the minor address field indicates a frame inside a particular configuration column. Sort of additional fields introduced back in the days, starting with the Virtex-4 devices, have been introduced in the frame address register to address portion of configuration resources other than the entire vertical column of the device array. In particular, the top-bottom bit addresses the top or bottom half of the device, and the row address is used to refer to a particular row of frames in the bottom or top half, depending on the chosen model. The figure aggregates all the possible information that is contained in a generic FAR word, either for the newest families and for older ones, like the Virtex 2 and Virtex 2 Pro FPGAs, showing what is addressed in each field. For the families that do not support a bidimensional granularity in configuration, like the Virtex 2 Pro, only one row of columns must be considered in the figure, while in the whole addressing scheme, inclusive of the row and top-bottom fields, holds for Virtex 4, 5, 6, and 7 series families. It's true that Virtex 2 and Virtex 2 Pro are no longer supported, but as we know, they have been quite important in FPGA's history. It's fair to consider them as the first devices used to bring partial dynamic reconfiguration to a general audience. Therefore, it is worth it to mention them also with respect to the topic we are discussing right now. The fields of frame address register thus divide hierarchically the configuration memory space. The top-level component is a row of resources addressed by the top-bottom bit and by the row address respectively. The next level in the hierarchy is defined by the column address, which defines which column in a row is configured. A frame within a column is then defined by its minor address, and there is no way to address configuration words within a single frame. The atomic configuration unit in Xilinx FPGA is thus represented by the frame, as the addressing hierarchy clearly shows. Finally, the frame data register, input register, or FDRI register, is used to write the words that make up a frame. The FPGA configuration logic implements the FDRI register as a shift register so that the frame is configured while the next one is being shifted in. For this reason, in the B stream there is some padding data in order to make the final write to the configuration memory. As previously stated, the FAR address is automatically incremented whenever a whole frame has been written to the FDRI register. The majority of a B stream is thus made of the words that are written to the FDRI register.